Okay, welcome to the fourth video for stoichiometry calculations. Just a reminder, keep these little steps in front of you just to help you work through. Now, if you're getting to this point and you're finding it's a little bit hard work and you're struggling a little bit, just want to encourage you. All right, nice glass of Farmers Union iced coffee will refresh you, help your mind get stimulated, and breathe new life into your stoichiometry calculations. So, what we're going to be doing today for the next one is looking at this one here. We're trying to calculate the concentration of a hydrochloric acid solution if we're using 24.2 milliliters of it to react completely with 20 mils of 0.0483 molar sodium hydroxide solution. So this is a really good example of a common titration that we often do in the lab. So first step, as always, is going to be a balanced equation. Okay, so we've got hydrochloric acid, HCl, and we're reacting that with sodium hydroxide solution. So this is a titration probably already done in the lab. Okay, acid-base reaction gives us a salt, which in this case is literally salt, and we get water. Nice balanced equation already, 1:1 mole ratio, which is going to make things nice and easy for us. Okay, so what we do is we then write down what we know. So we come over here to this one for our highlighter, and we're going to look at hydrochloric acid. We have 24.2 milliliters of hydrochloric acid. Okay, so what that means is volume is 0.0242. Okay, so we're converting it into liters. That's very, very important. And then what else we have here? We have 20 mils of 0.0483 molar sodium hydroxide solution. Okay, so what we can do is right in here we've got 20 mils, our volume is 0.0200, and we've got a concentration of 0.0483 molar. Okay, the question is asking us to calculate the concentration, so over here concentration equals question mark. That's what we're trying to work out. Okay, so we've done balanced equation, we've done writing down what we know. Next question is working out the known. What we've got for our known is the one with two values, which is this one here. So number of moles of sodium hydroxide is 0.02, all right, times by our concentration 0.0483. That's using N equals C times V. Okay, so apologies for my handwriting there. It's a little bit late at night, so it's looking a bit dodgy, sorry. So if this was an exam, you'd go through and you actually calculate that value. You don't need to worry about that at the moment. Okay, so next step is calculating our mole ratio. We use our unknown, which is hydrochloric acid, over number of moles of sodium hydroxide, which is our unknown. Looking up here at the equation, in front of the hydrochloric acid we have a 1. All right, so it's 1 over, and then up here in front of the sodium hydroxide we also have a 1. So it's 1/1 as well. It's a nice reaction equation. Okay, so we're going to take this mole ratio here, and we're going to take our number of moles here to calculate our number of moles of our unknown. Okay, so our unknown that we're trying to work out here is the hydrochloric acid. So it's the number of moles of the sodium hydroxide solution that we had. Okay, which was 0.0483 times 0.02. All right, and we're going to multiply that by our mole ratio, which was 1/1. Okay, so that's our number of moles of our unknown now, and we get to then answer our question, which was asking us to calculate the concentration of hydrochloric acid. So C equals N over V. So we're going to take our number of moles up here, which is here, and we're going to put that into our equation. All right, so it's going to be 0.0483 times 0.02 times 1/1. We don't need to put that in, so that's our number of moles. Our volume that we had was our titer value of 0.0242. Okay, putting that in, we're going to get a value of 0.0399 moles per litre. Okay, now this one is to 3 significant figures, because if we go back and have a look at our question, all right, we had 3 significant figures up here for the volume, 3 significant figures there for the volume, 3 significant figures there for the concentration. Everything's in 3 significant figures, so our answer needs to be to 3 significant figures as well. Okay, Hope you've been able to follow this one. Suggest you go back and try it before you move on to the next one. This is just an example of a very common concentration calculation for a titration, and in the exam they'll probably sort of step it out before they take it to probably a little bit of a further question doing some conversions. Alright, thanks guys, see ya.